Hello everyone. In this video I have brought case study based MCQ question for term 1 exam 2021. So let us now try to understand the first case study, which is based on dielectrics. Dielectrics are insulating non-conducting materials that can produce electric effect without conduction. Movement of free charges is not possible in a dielectric, so they behave differently. When a dielectric material is kept in an electric field, then the external field induces dipole moment, due to which net charges on the surface of the dielectric appears. Now go through the question number 1. When a dielectric material is kept in an electric external field, then the induced field will be less, more, both A and B constant. Here the correct answer is A, less. Now in question number 2, in the absence of electric field, the net dipole moment of a polar dielectric is 0, infinite, positive, negative. Your correct answer is option A, 0. Now question 3, the molecules that has no permanent dipole moments are option A, polar dielectrics, B, non-polar dielectrics, C, both A and B, D, none of the above. Here your correct answer is B, non-polar dielectrics. Now case study which is based on dielectrics. The fourth question is, the SI unit of dielectric strength is volt per meter, voltmeter, meter per volt, meter square volt. Your correct answer here it is option A, volt per meter. Now question number 5. Which of the following is the examples of non-polar molecules? Oxygen, hydrogen, nitrogen, all of the above. Here your correct answer is all of the above. Another case study which is based on electrostatic potential energy. Here you can see what is given in the passage. You go through the passage, then you try to give the correct answer of question number 1. Work done in moving a charge from one point to other inside a uniformly charged conducting sphere is always 0, non-zero, maybe 0, none of these. Correct answer is A, always 0. Another question, number 2. A positively charged particle is released from rest in an uniform electric field. The electric potential energy of the charge remains a constant because the electric field is uniform, increases because the charge moves along the electric field, decreases because the charge moves along the electric field, decreases because the charge moves opposite to the electric field. Here your correct answer is option C. Question number 3. Three charges are placed at the vertex of an equilateral triangle of side L as shown in the figure. For what value of capital Q, the electrostatic potential energy of the system is 0? Option A, minus Q, B, Q by 2, C, minus 2Q, D, minus Q by 2. Here you go through the hint. You find the total electrostatic potential energy of the system, which is equal to 0. So after writing the total electrostatic potential energy of the system equal to 0, you will get the value of capital Q equal to minus Q by 2. So option D is the right answer. Here it is, option D. Now question number 4. In the figure, proton moves a distance d in a uniform electric field E as shown in the figure. The work done on the proton by electric field is option A, negative, B, positive, C, 0, D, none of these. Here your correct answer is option D, none of these. Now the fifth question. Two similar positive point charges, each of 1 microcoulomb, have been kept in air at a 1 meter distance from each other. What will be the potential energy? Your correct answer, here it is, option C, 9 into 10 to the power minus 3 joule. Now another case study which is based on electric field. Here you go through the passage. then you try to give the correct answer. An electric field line in general is a curve drawn in such a way that the tangent to it at each point is in the direction of electric field at that point. A field line is a space curve, that is a curve in 3 dimensions. Electric field lines are thus used to pictorially map the electric field around a charge or configuration of charges. The density of field lines is more near the charge. Away from the charge, the field is weak, so the density of field lines is less. Now here you can see the first question. Electric field lines always move from higher to lower potential, lower to higher potential, infinity to zero potential, none of the above. Your correct answer is option A, higher to lower potential. Question 2. Choose the correct statements regarding electric lines of force. Option A, emerges from negative charge and meet at a meet at a positive charge. Option B, a closely spaced region of electric lines of force represents a strong electric field. C, representation of field lines for a point charge and a solid sphere are same. D, they have physical nature by spacing between two electric field lines indicate. Okay, the correct answer is B. Question 3. The spacing between two electric field lines indicates its charge, position, strength, none of the above. Your correct answer is C, strength. Question 4. The electric field lines of negatively charged particle are radial and outwards, radial and inwards, circular and anti-clockwise, circular and clockwise. Here you can see the correct answer, option B, radial and inwards. Question 5. What kind of charges are 1, 2 and 3? Here you can see in the figure the position of 1, 2 and 3. Then you have to decide for the correct answer. So here your correct answer is option C, Q1 positive, Q2 negative, Q3 negative. Now the next case study, which is based on induced current. The steady current in the coil C2 as shown below produces a steady magnetic field. As coil C2 is moved towards the coil C1, the galvanometer shows a deflection. This indicates that electric current is induced in the coil C1. When C2 is moved away, the galvanometer shows a deflection again, but this time in the opposite direction. This deflection is based upon the Faraday's laws of electromagnetic induction. Now here your question number 1 is, the change in magnetic flux increases the radius of the coil C1 to half the initial radius, induces EMF in the coil C1, increases the radius of coil C1 to double the initial radius, none of these. Your correct answer here it is option B, induces EMF in the coil C1. Now question number 2. Which of the following statement is or are correct? Statement 1. The steady current in the coil C2 produces a steady magnetic field. Statement 2. If coil C2 is moved towards the coil C1, the galvanometer shows a deflection. Choose the correct option. Here option 1, only 1. Option B, only 2. Option C, both 1 and 2. D, neither 1 or not 2. Your correct answer is C. Both 1 and 2 are right. Now question number 3. What will be the direction of deflection of galvanometer when C2 is moved away? Option A, same direction. B, opposite direction. C, no deflection. Neither A and B. Your correct answer is option B, opposite direction. Now the fourth question is, for duration of deflection in G, that is current flows in coil C1, which of the following statement is correct? The deflection lasts as long as C2 is in motion. Number B, the deflection lasts till 1 minute after motion of C2 stops. Option C, the deflection lasts till 1 hour after motion of C2 stops. Option D, the deflection lasts forever. Your correct answer is option A. Now the fifth question. When the coil C2 is held fixed and C1 is moved, then option A, same effects are observed, that is current is induced in coil C1. No current is induced in the coil C1. Option C, number of magnetic field lines through C1 do not change. Option D, current in coil C2 increases drastically. So here your correct answer is option A. So in this way we have come to an end. Do not forget to like, share and subscribe. Thank you. Thank you very much for watching this video.